Okay, in this video I want to talk about how to solve a compound inequality, which is a problem like this one, where we have 15 is greater than 2x plus 1, which is greater than 3. So in order for this statement to be true, I need to find an x that makes both inequalities, 15 greater than 2x plus 1 and 2x plus 1 greater than 3, true at the same time. So we have a couple of options of how we want to solve that. I'm going to start off by showing you one way, and then we'll show you the other way next. So our first option is to treat it as two separate problems, two separate inequalities, and then just solve them normally. So 15 should be greater than 2x plus 1, and 2x plus 1 should be greater than 3. And then solve for x in each case. So subtract 1, 14 is greater than 2x, and 2x is greater than 2. Divide everything by 2. That's a positive number, so I don't have to worry about flipping the inequalities. And we get x is smaller than 7, or 7 is bigger than x. And over here we get x is bigger than 1. Okay, so I should combine my answer as a compound inequality the same way the original was. 7 is bigger than x is bigger than 1. That would be my answer. Or in interval notation, this would be numbers between 1 and 7. Both parentheses because both less than, and the 1's on the left because when I think about it on a number line, 1 would be on the left. Numbers between 1 and 7, 1 is the left endpoint, 7 is the right endpoint. In set builder notation, this would be x such that 1 is less than x is less than 7, or 7 is less than x is less than 1. Okay, that's one option. Split it up into two separate problems. But you'll notice when I actually did the steps, it was the exact same steps over here as it was over there. Why not just leave it as a single combined inequality and just solve it that way? So that would be my other alternative, and probably that's the way I would solve this problem, is 15 is greater than 2x plus 1 is greater than 3, and then just do operations to all three parts. Treat it as though you're solving two equations at the same time, so instead of just adding or subtracting a number on both sides, we'll have to do the same thing to all three parts. So I would subtract 1 from each piece, and then divide everything by 2. One thing to be really careful of, the mistake I see most commonly is people that try and do this, like subtracting 3. Maybe they remember to subtract 3 from all three places. And then we get something like that, and then we add 2, and then we get 14 is bigger than 2x, and then we divide by 2, and we get x is smaller than 7. And the mistake I made was way up here. Like, just because 3 minus 3 is 0 doesn't mean I don't have to write it. I do have to write it. So just be really careful if you're using a compound inequality that we have to keep all of the parts of the compound inequality all the way through the problem. So I'm going to erase this because this is incorrect. I shouldn't be saying 3 minus 3 doesn't even exist. What I should be doing instead is trying to get my x by itself in the middle. So to get x by itself in the middle, I need to deal with the 2 and the 1. So I will subtract 1 from all three sides at the same time. To get 14 is bigger than 2x is bigger than 2. And then divide everything by 2. And since I'm dividing by a positive number, I don't have to worry about flipping the direction of my inequalities. And at least in my mind, this is less work and less writing because I didn't have to write this entire middle column twice, and I didn't have to then combine it as a compound inequality at the end. It's already a compound inequality. So if I can use this method, I usually do use this method. Okay, let's try another example. So I'm going to try and solve 5 is less than 2 minus 3x is less than or equal to 11. And I'm just going to try and do it as a combined inequality. A compound inequality. And so let's see, I want to get x by itself in the middle. So I will subtract 2 from each side. So I get 5 minus 2 is 3, is less than minus 3x, is less than or equal to 9. unfortunately, I don't have a lot of options here. I am going to have to divide by a negative. It wouldn't be super helpful if I added 3x to make it positive, because then I'd have 3x on the two edges. I want the x to be in the middle so I can say x is in between these two numbers. So I think I want to leave that as it is. So I guess that means I have to just live with the fact that I'm dividing by a negative. Okay, but I do have to be careful, because when I divide by a negative, we're supposed to flip. Less than turns into greater than. Less than or equal to turns into greater than or equal to. But I have to be careful which sign turns into what. So the one between the minus 3x and the 9 is less than or equal to. So between the minus 3x and the 9, that should flip to a greater than or equal to. The one between the 3 and the minus 3x, it was a less than, it should turn into a greater than. So just, if you're keeping track of your steps from top to bottom, we should have the same kind of symbol. Not necessarily pointing in the same direction, because we can flip directions, less than to greater than. But they should all be one of those two, and not less than's turned into less than or equal to's. Okay, at this point we can simplify a little bit. 9 divided by minus 3 is negative 3. Negative 3's cancel in the middle. And 3 divided by minus 3 is negative 1. And so it looks like our answer is numbers between negative 3 and negative 1. So on my number line, numbers between minus 3 and minus 1. And we have a less than, or sorry, a greater than between the minus 1 and the x. So we have an open circle at minus 1. We have a greater than or equal to, meaning a filled in circle at minus 3. So it would look something like that. My interval notation would have a bracket on the left and a parentheses on the right. And minus 3 is on the left, so I need to put minus 3 comma minus 1. Set builder notation, maybe instead of x such that copy this, or I think I'm going to write it in numeric order. Negative 3 is less than or equal to x is less than negative 1. So that would be my answer.